What's up, calculus students? Let's do the last lesson homework on the chain rule. Chain rule is how we deal with derivatives that are compositions, where we have an outside and an inside. The chain rule says that if you find the product of the derivatives of the composed functions, that's the derivative. Okay, chain rule discovered by placing something theoretical in Newton's famous formula. He developed this rule. And here's how it works. You take the derivative of the outside, the derivative of the inside. Outside's derivative, pretend like there's an x there. So like 3 stuff to the fourth, 12 stuff cubed. 2x cubed plus 1, 6x squared plus 0. These are the derivatives, product of the derivatives of the composed functions. 12 times 6 is 72. I can do that because you're multiplying 12 times this times 6 times x squared. So you can multiply anything in any order. So I can put the 6 and the 12 together to give us 72. I can put the x squareds out in front. And then I have x cubed. Whatever starts on the inside stays on the inside. So maybe like it's better to show this as 72x squared cubed, stuff cubed. But whatever starts on the inside stays on the inside, like Vegas. Okay? And this is f prime, the equation of the tangent slopes. And you can plug values into this to get slopes of this. You could set this equal to numbers to get where this equals those slopes, stuff like that. So all the same stuff. Now, notice the difference between this one and this one. Yes, this is a product, but there are no x's. Since there's no x's there, you don't have to use the product rule. This is different. Yes, this is a product, and since there are x's, you have to use the product rule. And a lot of students really get confused by that. They try to use the product rule all the time. You don't have to use the product rule all the time. You just got to figure out when to use the right rule at the right time. So this is a product rule, which means we got a first and a second. We got to take the derivative of the first times the second. And then add the derivative of the second. Now, to take the derivative of the second, you need to use the chain rule. You need to do the O and the I. So I'm going to just do the 4. I'm not going to include the 3x, because if I include the 3x, that's a product. So I'm just going to have the parentheses to the fourth on the outside and the 2x cubed plus 1 on the inside. Take the derivatives of the composed functions, 4 stuff cubed. This is 6x squared. And then multiply these together, and you have the product, the derivative of the second piece. So the derivative of the second piece is 24x squared, stuff cubed. What's the stuff? Whatever starts on the inside stays on the inside. That's the derivative of the second piece, but then you multiply by the first. Okay? Now we could leave this if we wanted to, but we will see later in the lesson, later in the homework, sometimes it's helpful to factor this. And when you factor this, you will be able to set up a product to solve certain equations. We'll keep the factoring to the later questions. But essentially what we do is we think of this as being like a y. You can multiply the 24 and the 3 if you want to. That's 72 again. The x's are that, and that's y cubed. And then you try to factor out the greatest common factor from both those terms. So we'll do that later. Okay, very important to understand the differences with trig functions, how if you're writing something like sine cubed here, that can be written as sine of x cubed. It's important to see that rewriting so that you know oh, the outside is the cubed, versus this is the sine of the cubed root of x. I could write it with a cube instead. I'm not gonna this is not correct. This is another example to write it like that. So here you can see the signs on the outside. So here the situation is that the outside is the 1/3 power. Okay, not the cube. I'm just like, that was just an example. Hope there's more. I think there will be more. And then the inside is a sine. So the derivative will be 2 stuff to the -2/3. Remember to subtract 3/3 times cosine. Here the outside is the sine. So a trig function can be an outside, and the inside is the 1/3, x to the 1/3. The derivative would be 6 cosine parentheses, and then 1/3 x to the -2/3. So this h prime would be, you could multiply the 2 and the cosine first if you want to. 2 cos x times what starts on the inside stays on the inside. That's the sine x to the -2/3, if you'd like to rewrite that. 2 cos x over sine x to the 2/3. You can put this 2/3 power there instead. Just don't put it over the x, because that's not correct. Here, j's derivative, j's tangent slopes, I can multiply the 6 and the 1/3 together first. I can put the x to the 2/3 in the denominator. So the 6, the 1/3, the x is taken care of. I just have cosine. What starts on the inside stays on the inside, so that's x to the 1/3. Okay. 2 more like combinations. I wish we had just more like regular. I wish we had more just regular chains like this. For next year. Wish we had like a couple more of these, like with a square root or something. I think we'll see them. Okay, so here we got an outside and an inside. The outside is the cube. The inside is this quotient. So we're going to have to combine our chain rule with our quotient rule, where the derivative of x squared over x minus 1, you have to use the quotient rule, derivative of the top times the bottom, minus the derivative of the bottom times the top, all over the bottom squared. Now, if we want to write this out, we can make it like super complicated and just like write it out as you see it. 3 x squared over x minus 1 cubed times, this quotient rule derivative. But I'm going to show you how to simplify this, which is going to be, helpful if we were to solve equations, or, say it's a multiple choice question and they're asking you for the derivative. You're not going to see this derivative. You're going to see a simplified derivative as an answer. All right, so first things first, we could have done this to start. Cube the top and cube the bottom. I could have written this as x to the 6 over x minus 1 cubed. You could use the quotient rule and then the chain rule with this if you wanted to. But let's just do it now. So I don't really need the parentheses anymore because I've cubed the top of the bottom. Here I get 2x squared minus 2x minus x squared. So that's x squared minus 2x over x minus 1 squared. What you realize is like you could factor out an x from this. You can combine all of these x minus 1s. This x to the 6 and this x becomes a x to the 7th. And now you have one nice quotient where if like I asked you where are the horizontal tangents, you'd say, okay, 2 and 0 when the numerator equals 0. If you wanted to solve an equation, you potentially could by setting this equal to a number. It's a lot easier to deal with as a simplified derivative than it is as an unsimplified derivative. Okay. Let's just start with this being a number. This is a good example of like, let's do 2. Let's do L and let's do M. So we'll keep L as it is, and I'm going to write a different M. This is a good example that I wanted to see more of. And you know, I'm gonna change this to sign. I'm doing this just to give you another simple one. Okay, so change this to sign. If you didn't do it, I'll show you the answer. But actually, I'll just do it over here. 5 sine 2x. Okay, this is a great example, this one. It's a simple chain. Yes, it's a product, but since it's not x's times x's, you don't use the product rule. It's just a constant. So I would say that the outside is 5 sine parentheses. I'd say the inside is 2x. It's a good one because it's very simple, but very important to see. When you multiply the derivatives of the composed, when you get m prime, you get 5 cos 2x times 2. The derivative of the inside is 2. That becomes 10 cos. What starts in the parentheses stays in the parentheses. Okay? Important one to see so that you realize, like, it could be simple. 2x could be the inside, but the derivative of 2x is still 2. That's still something you have to worry about. Now, this one, more complicated because it's a product and it's a chain. Because they're x's, I have to use the product rule. I guess this is L prime. So I have the derivative of the first times the second plus the derivative of the second. Now, to do the derivative of the second, we need to use O's and I's. The derivative of secant stuff, tangent stuff, we remember that derivative from the last lesson, and then the derivative of 2x is 2. So the derivative of the second is secant stuff, tangent stuff. Make sure you write it as secant stuff, tangent stuff. I see a lot of students do secant tangent stuff. That's not right, okay? So it's the secant of 2x times the tangent of 2x times 2. You can't multiply the 2 in by this. That's the derivative of the second. Don't forget to multiply by the first. So L prime secant 2x plus 2x secant 2x tangent 2x. If you wanted to, you could factor out a secant 2x. Just if you see a multiple choice question. And this would be like the simplified derivative. Okay. This one, very important. Okay. The first one, like, make sure you understand the first one. And then make sure you understand, again, I got to change this. I'm going to write a little note to myself after this. Let's say h of x was 6 sine cubed x. Understand that you would rewrite this as 6 sine x quantity cubed. The outside is the cubed. The inside is the sine x. And then same here. If it's 6 sine x cubed, the outside is the sine. Okay, so just heads up. Now what we see for the next 4 are a composition not just of 2 things, but of 3 things. After rewriting f, because it's sine cubed, I realize this is the sine of 3x squared minus pi, all being cubed, which means we not only have an outside, but we also have a middle. Sine parentheses is a middle function, and then the inside is the 3x squared minus pi. You will have to take the product of all of these functions' derivatives. Okay, these are the composed functions. Chain rule says take the product of the derivatives of the composed functions. So we'll have to multiply together 3 parentheses squared with cos parentheses with 6x minus 0. The derivative of pi is just a number, 0. Now, again, since we're multiplying all this together, you can multiply anything by anything. Okay, just don't multiply into parentheses. So I will multiply the 3 and the 6x to give me 18x's. Then I have a parentheses squared and a cosine of parentheses. Now here's what's important with this multiple chain rule with an O and an M and an I. It's whatever starts in this parentheses goes in that parentheses. And whatever starts in that parentheses goes in that parentheses. So it's whatever starts in here goes in there. Whatever starts in here goes in there. So like whatever started in the cubed was everything. Everything started in the cubed. The sine started in the cubed and the 3x squared minus pi. So that needs to go back in there. What started in sine was not everything. You're not going to rewrite sine here. But what started in the sine was the 3x squared minus pi. So it's almost like this goes in there and that goes in there. So that and that will go in there, if that makes sense. If you just like do a couple of these, I think you'll be able to figure it out. Okay. So we end up with this for f prime. Remember what we can do with this. We can plug in values to this to get the slopes of f. This is a good one. I wish it was just 3 secant. I just wish it was secant. That way you know like it's an O and I, O being the 1/2, I being the secant, but this is an O and an M and an I. With the O being the square root, which is a 1/2 power. We know power rules can work with roots. We got secant stuff, and then we got 3x. All right, so let's take the derivatives of all of the different functions. Secant stuff, tangent stuff. We did that earlier. And then 3. Multiply things in any order. The 3 and the 1/2 can be multiplied together to give us 3/2. I have stuff to the negative 1/2. And then I have secant stuff, tangent stuff. What starts in the parentheses stays in the parentheses. This goes in there, that goes in there. So we get secant 3x goes in here, and then 3x goes here and here. How can you rewrite this? I got the 3/2. I got secant 3x tangent 3x. I'll move this to the bottom. And now watch what I'm going to do. If I ask you what is x over root x, like how can you simplify? Well, we know if it's like x to the 5th over x squared, we try to like cancel, we could subtract 2 x's and 2 x's here to give us x cubed. So you just subtract the exponents. Well, this is 1 and this is 1/2. You can simplify this to be just 1/2 in the numerator. This is secant 3x to the 1st. This is secant 3x to the 1/2. You could subtract these, and it's important to be able to do this in case you're asked to simplify, leaving me with a square root or a 1/2 power for this secant in the numerator, and then a tangent. Being able to do this is helpful. We might be asked to do it on a multiple choice question, and if you're solving equations, making these simple simplification steps, as long as you know what you're doing, is going to be helpful. Oh, look at J. I don't want to do J. Let's look at H first. H is an O and an M and an I. First thing is first, to understand tangent cubed is tangent stuff cubed. OMI would be cube is outside. Tan, stuff, middle. Pi x inside. Derivative of tangent secant squared. Derivative of pi x, pi is just a number, it's just pi. So h prime is 3, big old set of parentheses, squared. Secant squared of stuff, pi. What started in parentheses stays in the parentheses. And I get that. Nothing I can really do to simplify this. Maybe I can write tangent squared as sine squared over cosine squared. Secant is 1 over cosine squared. Secant squared is 1 over cosine squared. Maybe it's like cosine to the 4th if you wanted to, but this is fine. I haven't asked you, but be ready to plug values into this to get the slopes of H. They might be gross, messy values, but they are values nonetheless. Yeah, this is like designed to be confusing. This is not everything squared. This is just sine 3x squared. What you realize is like you have a product of that stuff and that stuff. So you got to use the product rule. I'm like purposely giving you very tricky ones, but like the easier ones are like the most important. So for the first derivative, you have this OMI composition. You have the square, the sine, and the 3x. I'm not worried about cosec yet because that's the second piece. It's a product. So I got 2 stuff, cos stuff, 3. Okay, now when I'm doing J prime, I have to use the product rule. So I have the derivative of the first. The derivative of the first is this stuff. 6. That goes in there, that goes in there, which goes in there, you know. So sine 3x, the 2 and the 3, and then cos 3x. So I have the 2 and the 3 that's gone. I have the sine 3x, which goes in here. I got the 3x in there, good. So that's the derivative of the first piece, but then I have to multiply by the second. Add the derivative of the second times the first. There's nothing I could do actually to simplify. You cannot multiply this cos x with this cos x. It's not cos squared 3x squared. Doesn't work like that. You're done. If anything, you could factor out a sine 3x. I don't know if that helps you at all. So that's the derivative. Good practice of like chain rule and the product. Okay, so now we get into, hey, find the locations of the horizontal tangents to these functions. This is when we're going to have to take the derivative, set it equal to 0. Horizontal tangents when our slopes equal 0. So when our tangent slopes equal 0. We're going to have to solve equations. To solve equations, it helps to have factored simplified forms. We saw that with the product rule and the quotient rule last 2 lessons ago. So what we realize is that it's x's times x's. I have to use the product rule. And here's what I'm going to get. The derivative of the first times the second plus O and I for the derivative of the second. I got a 6th power, and I got x squared minus 4. That gives me 6 stuff to the 5th, and then 2x. Multiply these together, I'll get 12x, x squared minus 4 to the 5th. That's the derivative of the second. Don't forget the first. Now we have to solve this equation set equal to 0. Not easy to do if it's the sum, okay? We like products equal to 0. That's why we take quadratics and factor them. So we have a product equal to 0. As long as we have pieces of the product equal to 0, we win. This is when it's important to simplify and to factor. Now, how do I do that? Well, like I'm going to rewrite this, and instead of as x squared minus 4, I'm going to write it as just like a y. Okay, I think this really helps students when they see this. Over here, I can multiply the x and the x squared. I can't multiply inside the parentheses because it's to the 5th power. But I do get 12x cubed, and then I'm going to write this as y to the 5th. Now, if I asked you to factor out a greatest common factor from this, you'd be able to do it. What do they share? They share a 2. They share an x. And they share a y squared. Okay? I factored everything out of the first piece, which means I just have 1 left over, right? Like I divided it out, we have 1. Over here, I pulled out a 2 and an x, so I'll have a 6 and an x squared left over. Oh, shoot. I really messed up here. Sorry, guys. That's a 6. Yo. Be neat and orderly, or you're going to make mistakes. All right, hold the phone. What do I share? A 2, an x, and 5 y's. All right, that's going to look different. I pulled out the 2 and the x and 5 of these y's. I have 1 of the y's left over. I pull out a 2 and an x and 5 of these y's. I'll just have 6x squareds left over. Okay, that's better. Now, I did all this work, rewriting, factoring, so that I realize 2x times x squared minus 4 is replacing y, because I replaced it to the 5th, times x squared minus 4 to the 1st plus 6x squared. Now we have a product. I got 2x, I got x squared minus 4 to the 5th, and I can add these together to get 7x squared minus 4. I did all of this so that I now can solve this equation. This, or this, or this, as long as any of those pieces equal 0, I'm going to have a horizontal tangent. So from 2x, 0 is a solution. From x squared minus 4, you could factor it, or just set the inside equal to 0, add the 4 square root. You get positive and negative 2. From 7x squared minus 4 equals 0, I add 4, I divide 7. I'll get plus or minus, because I'm square rooting an unknown squared, 4/7. So that's negative root 4/7, positive root 4/7. If you wanted to simplify this, you can write this as 2 over root 7, because the square root of 2 I can do. If you want to rationalize it, you get 2 root 7 over 7. But I don't know. This is fine. We don't care about rationalized answers. Now let's just see the beauty in what I just did. Okay, watch. I probably should have just gone to decimals. Let's go to decimals. Let's graph y equals x squared times x squared minus 4 to the 6th. All right. All right. Boom. Negative 2, 0, horizontal tangent right there. 2, 0, horizontal tangent right there. 0, 0, horizontal tangent right there. We have a couple more horizontal tangents. Okay, we're increasing a lot in between things. Okay, there we go. Okay, I got a horizontal tangent here and here. This, negative 0.576. This, positive 0.576. Guess what? Take the squirt of 4 over 7. 0.576. 0.576. We just found that location right there using calculus. Okay, so there you go. That's the beautiful thing. Now, as intense is involved, but we can do it. We can do it. All right, let's try this one. I have another product of x's and x's. So I have to use the product rule. Derivative of the first times the second. If you didn't know what to do for the first one and you just watched me, try to do this second one by yourself. Okay, guys? Don't just copy things down. That's not going to help. Add the derivative of the second one. To take the derivative of the second one, I need to use the chain rule, an O and an I. The derivative of O, 4 stuff cubed. The derivative of I, 2x. I can multiply the 4 and the 2x together. Don't multiply by the stuff in there. So I get 8x, x squared minus 3 cubed. That's the derivative of the second piece. Don't forget to multiply by the first to conclude the product rule. So What do I have? I have y to the fourth. I have 8x squared y cubed. To factor this so we can set this equal to 0, I will factor out a y cubed. I'll be left with a y and 8x squareds. This is something I can do. Y cubed y plus 8x squared. Getting us x squared minus 3 cubed. 9x squareds minus 3. What are our solutions? Well, from here, positive and negative root 3. From here, I add 3 divided by 9, I get 1/3. So I get positive root 1/3, which is root 3 over 3. 1 over root 3 is root 3 over 3. And I'll have negative root 1/3. Graph the original equation in Desmos, you'll be able to see horizontal tangents at those locations. Wow, I'm really throwing this at you here. This is a product of x's, but each product is a chain. So the derivative of the first, o and an I, it's not that bad because the i's derivative is just 1. So I just have 2 times parentheses. So the derivative of the, I need more space. So the first derivative, o and I, stuff squared, x plus 1, 2 stuff 1. The second derivative, which we will worry about as we do the product rule, stuff cubed, 2x minus 3, 3 stuff squared, 2. Okay. Product rule, guys. Product rule. Let's slow down, pump the brakes. Don't just multiply all these together. The derivative of the first, 2x plus 1. Times the second, 2x minus 3 cubed. Plus, derivative of the second, 6, 2x minus 3 squared. Times the first, x plus 1 squared. You know, maybe you want to use a y and like, I don't know, a z, just so you could see that, okay? Setting this equal to 0 to solve, factoring is going to help us. I can factor out a 2 and a y and 2 z's from everything. The 2 and y, 2 z's are gone. I just have 1 z. 3, 1 y, both of the z's gives me 2's gone, leaves me with 3. One of the y's gone, leaves me with y. Both of the z's are gone. Boom, we get that. Okay. Why was this important? Because now we have the following: 2y, z squared, z, 3y. Two x plus 1, 2x minus 3 squared. This is 3x plus 3, meaning I have 5 x's. Oh, and that's it. Because minus 3 plus 3 is 0. Meaning this equal to 0, negative 1, 3 halves, and 0. I'm gonna look at this. X plus 1 squared, 2x minus 3 cubed. Wish I could just go back to Zoom standard. 10, 10, 10, 10. All right. Boom. Negative 1. That's 1. 0. There's another. 3 halves. Ooh, 1.5. That's one of those situations where we flatten out and then keep increasing. It's not like a max or a min. It's like a neither, which we'll learn about in the future. But we did it. Okay. All right. Throughout all of these, throughout any of them, what we didn't do is like plug in values. Like I didn't ask you to plug in values. It's like, yeah, I wouldn't ask you to do too many. Like, I don't know. I could ask you to plug in 0, but a lot of them would be 0. I'd ask you to plug in 1, but if you plug in 1 into this, it's going to be like a huge number. Okay. A lot of these functions increase really quickly. Like what am I plugging into sine is easy to plug in. Not many things, like pi over 2 maybe, but then it's like this is 0. So like, if anything, I'd probably ask you what's the slope of this at 2. But if I ask you what the slope of this at 2 is, okay, you realize it's 0. So like with some of these derivatives, it's like the process of taking the derivative, maybe solving, but like plugging in values, sometimes it's not easy to do, like and get nice numbers. Except for like something like this. Like I'm asking you to find the equation of the tangent line. All right, so let's remember equation of like the slopes is f prime. Equation of a tangent line is like the line equation. It's confusing to a lot of students. I've been using the word equation more this year than I have in the past. I used to just say like f prime is the tangent slope generator rather than it's an equation. So anyways, hope you understand that. Like equation of a tangent line means an equation of a line where the slope comes from, your y prime at pi over 6. We get our tangent slope generator, we plug in pi over 6. That's the slope. See a lot of students make mistakes with this kind of concept. What they do is they think that the derivative of 3 cosine is -3 sine. They think that this derivative is the slope. So they like plug this entire function into m. No, that's not a slope. That's a slope generator. Derivatives are slope generators. You plug in x's to get y's. Those y's on f prime, on y prime, are slopes of y or f. Okay, so no product. Again, you see a product, but it's not x's, so don't use the product rule. You get -15 sine 5x. Cool. This is not the slope. It's a slope generator. Plug in pi over 6. We get this. The sine of 5 pi over 6, you should know. Short 30, 60, 90 triangle. Shorter side is the vertical side. It's a 1/2, second quadrant. Side's positive. So I get -15 times 1/2, so -15 halves. That goes here. That's the slope. We're at pi over 6. Great. Don't forget, what else do we need? The y-coordinate. The y-coordinate here. So don't forget to plug in pi over 6 into the original. Cosine of 5 pi over 6 is -√3/2. So this is -3√3/2, or this becomes plus positive. I can do this quickly. 3 cos 5x is going to go up and down very quickly. Going to just subtract the 3√3/2 minus 15 halves, x minus pi over 6 minus 3 squirt 3 over 2. At pi over 6, somewhere around here. It's pi over 6. About 0.5. So somewhere around 0.5, yeah, 0.52. Boom. Right around there, boom. That's where your line and your function meet. There's your tangent. Beautiful. Okay. All right. With the chain rule comes like table problems. We did these last class. Nothing to worry about, but it is notation where like f parentheses g parentheses x, not a product. A product of two functions would be written as f of x times g of x. It's like x's times x's. That's a product. This is g is inside of f. It's composed. 3, it's not x's, not a product. Don't think of it as a product rule. So when asked to take the derivative of this, you got to recognize that it's not a product. You got to recognize that it's a composition, it's a chain, and you got to O and I it. Now, just like we say f's derivative is f prime, f's derivative is f prime, f parentheses derivative is f prime parentheses. G's derivative is g prime. You don't have to use the chain rule with g of x, like you might see parentheses here. But if you use the chain rule for g of x, you realize it's like, oh, that's unnecessary because the derivative of the inside is just 1. So the derivative is just g prime of x. If there's anything else inside here, like a 2x or a 3x, oh, then we have to be careful. So h prime, multiply these together, 3f prime. What started in the parentheses? G of x, that stays in the parentheses. Okay, so that's good for being able to do the derivative. Now the next thing is to plug in 3. And this is where like, yo, pump the brakes. Again, this is not a product. It is what is f prime of g of 3. You go into your table, g of 3 is 4. You need to now find f prime of 4 and multiply it by g prime of 3. G prime of 3 is -2. F prime of 4 is -4. So I have 3 times -4 times -2. So that's 24. Okay? Positive 24. That's all that goes into these problems. Same here, only g's the outside and f's the inside. Now, notice I don't do an OMI because the inside's derivative x is just 1. It's just f of x is the inside. So j prime is 2g prime. What starts in the parentheses stays in the parentheses. F of x times f prime of x. Plugging in 3, j prime of 3 is 2g prime f of 3 times f prime of 3. F of 3 is 2. F prime of 3 is -3. G prime of 2 is -1. We get 6. Okay. Now, it doesn't have to be f and g to be a composition. Here, the outside is 2f and the inside is x squared. Well, like, you can take the derivative of x squared, so we should be using the chain rule here. We should O and I this. Now, when we multiply this together, the 2 and the 2 is 4. So I have 4 times x times f prime of what starts in the parentheses stays in the parentheses. Plugging in 2 for x, 4 times 2 times f prime of 2 squared is 4. I have 8 times f prime of 4. F prime of 4 is -4. So 8 times -4 is -32. Okay, this guy is an O and an I. Outside is the square, the inside is f of x. Derivative of the outside 2 stuff, the derivative of the inside f prime of x. Don't need to use the chain rule with f of x. The derivative of the inside is just 1. So multiply these together. I have 2. What starts in the parentheses stays in the parentheses. So 2 f of x times f prime of x. Plugging in 2, f of 2 is 4, f prime of 2 is negative 2. F of 2 is 4, f prime of 2 is negative 2. So I got negative 16. Square root of g. Yeah, this is like g parentheses to the 1/2. It's a composition. 1/2 is the outside, g of x is the inside. 1/2 stuff to the negative 1/2, g prime. So that's r prime. 1/2 g of x to the negative 1/2 times g prime of x. Plugging in 3, 1/2 3 g of 3, which is 4. G of 3 being 4 to the negative 1/2. G prime of 3. G prime of 3 is negative 2. This 4 to the negative 1/2 is the same as positive 4 to the positive 1/2 in the denominator. I'll end up with negative 1/2 after all said and done. This is just 2. It's 1/2 times negative 2. It's negative 1/2. Here's a good one, a little tricky one. A lot of people think O and I, and O is X, F, but like, no. This is a product of X's and X's. If you have a product of X's and X's, you have to use the product rule. So actually, a little trick thrown at you. To take the derivative of this, you have to use the product rule. Derivative of the first times the second plus. Now when I take the derivative of the second, I got to O and I it. So that I realize I get f prime of stuff times 2. So that's multiplied together. I'll put the 2 in front. 2f prime of 2x, and then times the first, which is x. Derivative of the first times the second plus the derivative of the second times the first. It's a Q. So plugging in 2, I have f of 4 plus 2 times 2 is 4, f prime of 4. F of 4 plus 4, f prime of 4. F of 4 is 3, f prime of 4 is negative 4. Negative 16 plus 3, negative 13. Okay. Guys, the same happens with graphs. Remember, just like you get points, those are function values, slopes at the points. You can find the slopes because they're straight lines. Slopes of tangents are going to be just the slopes of the lines. This is not an OMI, but this is. This is a constant times a composition, so I can just consider the constant as part of the outside, not using the product rule because it's not x's times x's, just repeating that as much as possible so that we don't make that mistake. 3f prime is the derivative of 3f. Don't use the product rule. It's just unnecessary. You can, it would work, but it's just a waste of your time. Okay, so this is 3f prime of what starts in the parentheses, stays in the parentheses, g of x. All right, plugging in 1. This is where we get a little bit complicated, so just pay attention. I'm not finding f prime of 1. I'm finding f prime of g of 1. G of 1 is 1, 2, 3, 4. So this is 3 times f prime of 4. G prime of 1 is the slope of g at 1. The slope of g of 1 just happens to be 1. But if you forgot that, or if it's any other number, just you'd get it wrong if there was any other number. This 1 being 1, you could have forgotten this and still get the right answer. Anyways, f prime of 4, 1, 2, 3, 4, the slope of f, which is the black line at 4, is up 2 over 1, is 2. So this is 3 times 2 times g prime of 1, which is 1. You get 6. Okay? Now, since this is a g of f of 2x, that 2x being something other than just x, you have to OMI it. Where the outside is the g, the middle is the f, but the inside is 2x. Because 2x has a derivative that's not 1, it's 2. F's derivative, g's derivative. So, what do we got? G prime of what starts in the parentheses stays in the parentheses. F of 2x times f prime of 2x times 2. Okay? Plugging in 2. G prime of f of 4. I got to find f of 4. Then find the slope of g at that point. Got to find f prime of 4, multiply by 2. So let's look at f at 4. 1, 2, 3, 4. I got 1, 2, 3. Good. This works out. So f of 4 is 3. F prime of 4 is 2. So this turns into g prime of 3 times the slope, which is 2 times 2. You got to make sure you do these. G prime of 3 is the slope of g at 1, 2, 3. The slope of g is negative 2, then 1, 2, 3 over 1. Negative 2 times 2 times 2. Negative 8. All right, and last one. O and I this. G is the outside, x squared is the inside. Derivative of x squared 2x, the derivative of g prime. Multiply these together to get z prime. G prime of x squared times 2x. I'm plugging in negative 2. I get g prime of 4 times negative 4. G prime of 4, 1, 2, 3, 4. G is negative 1. Ooh! I thought this was negative 2. Did I mess up over here? Yeah, I was wrong. This is negative 3. One, 2, 3, 1. Down 3 over 1. This answer is not negative 8. This answer is negative 12. This is negative 3 times negative 4, which is positive 12. Okay? Listen, I think I probably made the homework a little bit more difficult than necessary. Like, here's a good question. Like, this question's on your quiz. What's the slope of this at x equals 1? Okay? Great chain rule problem. Okay? Simple chain rule. Where you don't have to worry about products and chains. It's just a chain. The outside is a 1/2 power. The inside is x squared plus 2x plus 1. We didn't see many of these. I gotta change the homework for next year. I already changed it for this year, but for next year, I need to change it again so that it has more of these like easy problems, more equations of lines, more find the slopes. Like you can do this. And what's great is that when we're doing this product of these things, it's like 2x plus 2. So like I get this, but I'm not able to quickly multiply this and this. I get just like 2x plus 2. Okay, now if I plug in 1, I'll have 1/2 4 to the negative 1/2 and then 4. So 2 over 2, which is just 1. Like it's a nice easy number that you can get. And that's a good chain rule problem, you know, where you don't have to worry about products and chains. I think I focused on products and change because so many people mess up on products and change. They always think that it's just a chain and you don't have to worry about products. But make sure you can do like the basic ones. You'll see like on your test, a lot of them are as easy as this, where you just know that you'll have an outside and an inside, and then you can multiply the 2 and the 5 together to get 10. Those, like, you got to be able to do those. Those are like what most shows up. On your test, you'll have like an OMI. You'll have some table problems. But make sure you have the basics down before you really worry too much about the whole product thing. Though, yes, there will be like a product that you'll have to factor and stuff on your test as well. So, anyways, hope we understand things. Hope we get the gist of the chain rule. We'll practice. We'll take our quiz, review day next class, test the following class. Later.